Welcome to this introductory video on graphing quadratic equations. By the end of this video, you should be able to determine whether the graph of a quadratic function will open up or down, and you should be able to sketch the graph of a quadratic function and identify the axis of symmetry, the vertex, the domain, and the range. Alright, so we're still talking about quadratic equations. We're working with quadratic equations that are in standard form at this point. We will have different forms that we encounter soon. So ax squared plus bx plus c equals 0. Remember, a is always next to the x squared term, b is always next to the single variable, and c is your constant. It does not have a variable. It's very important to be able to tell which number is which because we'll still be using quadratic equations. The formula to solve some stuff as we move on. Alright, so we're going to take a second. We're going to do a little quick investigation. So the graph of a quadratic equation is a U-shaped curve called a parabola. So when we draw these, we want to make sure that when we turn around to change direction, that it is a curve and not a point, because that will be a different kind of graph. So let's use our graphing calculator, or Desmos if you do not have a graphing calculator, and we're going to put this equation in. So you're going to touch the y equals to go into where we will put the equation. X squared, remember x is next to the green alpha button right here, so x, and the squared button is over here on the left. X squared plus 2x plus 5, okay? Okay, so x squared plus 2x plus 5. So we're going to press the graph button right over here. Give it a second, and there we have, you can see the U shape. If you look, it crosses the y-axis at 5. So I'm just going to make a little note. 1, 2, 3, 4, 5. So I know it's going to go through right there. And I see the lowest point is just kind of a little bit over here. So I'm just going to kind of graph it like that. Alright, so this graph has no solutions because it never crosses the x-axis to relate it to what we were doing before. Now we want to try the other equation. So go back into y equals, erase what's there. Now if you notice, those two equations look an awful lot alike. What is different is this number in front. It's a negative one, so we say negative x squared plus 2x plus 5, and we're going to graph it again. And so it looks different. It still goes through at 5. 1, 2, 3, 4, 5. But it does go through the x-axis. So let's see. Let me kind of zoom this in a little bit, see if we can see a little bit better. There we go. So we missed the top of it just a little bit, but we can see it's going to go through the x-axis between 1, 2, 3, between 3 and 4. So 1, 2, 3, so I'm going to say it's somewhere like right in there. I'm going to give myself a goal to go through. And on the other side, between -1 and -2, so somewhere between there. And it's going to go up, it's going to go through the y-axis and curve and come on back down. And let's put some arrows on the ends of it. Okay, so now let's take a look. The almost identical equation between the two of these, and the difference is this equation has a positive one and this equation has a negative one. That is the only difference between them. And so the purpose of this is when we're looking at an equation, if the parabola is open up, the a value will be positive. So which way, when the a value is positive, your parabola opened up. And that will always be true. If you look at an equation and a is a positive number, your graph will open up. If a is a negative number, then your parabola will open down always. Okay, so that's just a quick way before we start graphing that we know which way the graph is going to open, up or down. One of the characteristics we want to talk about. So a characteristic is a way to describe the graph to somebody who can't see it. And we're going to have a number of characteristics that we're going to be able to describe so somebody who cannot see the graph knows kind of what it looks like. Kind of like if there's somebody goes to a police sketch artist and they make a sketch of a suspect. It might not be exact, but you have a good idea of what the person looks like. All right. So to find the axis of symmetry, the axis of symmetry is the imaginary vertical line that divides a parabola into two equal halves. So if we had our U-shaped parabola, the axis of symmetry is going to come right down the center of it, just like that. It could open down, but the same thing will happen. The axis of symmetry is going to go right through the very center. So if we were to fold this parabola on that line, this arm will match up with the other arm. It's a symmetrical spot. To find where that line is, you're going to use x equals negative b divided by 2a. And I'm hoping that looks a little familiar, because if we look at our formula sheet, at our quadratic formula, notice that it has negative b and 2a. So it's using this piece of the quadratic formula to tell you where this axis of symmetry is, and that helps you know where the graph is going to be centered on, so when you go to graph it. All right, so one characteristic is this axis of symmetry, and another very important characteristic is called the vertex. So when we have a graph, we're going to have our axis of symmetry come through, and there's this very center point that the axis of symmetry goes through. That's called the vertex. It is the very center point of the parabola, and it's where the parabola turns around and changes direction. So it's going down, 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 and it hits the vertex, and then it starts going up. And that can also be called a turning point. So the x value of the vertex is the same as the x value for the axis of symmetry. So once you use this negative b over 2a to find the axis of symmetry, you already know the x value of the vertex. And we're going to use our calculators or Desmos to find the y values, or you can plug in the number and calculate it out by hand. So when your parabola opens up, your vertex is the very lowest point. It's on the bottom of the graph, so we call that a minimum. Okay, so when your parabola opens down, so we have a parabola, we have a vertex, we have the axis of symmetry. It's going to be on top of the graph, so it is called the maximum. So the minimum is the lowest point, and the maximum is the highest point. Okay, so those are, you just have to be able to identify, is this graph going to have a minimum or will it have a maximum? Okay. One last thing we have talked about previously, but we're going to apply to our quadratics here, is our domain and range. Okay, so remember, domain is all the x values and range is all of the y values included in the graph. So we're going to kind of put a bunch of stuff together and see what we get. We're going to do a little sketch. This graph opens up because my a value is positive. So I'm just going to sketch a up facing parabola. I know the axis of symmetry is going to come right down through the center of this, and I know my vertex will be right in that same spot. So I already know I've got a minimum because it's on the bottom. If I want to find the axis of symmetry, I'm going to say negative b, so b is positive 8, so negative b divided by 2a, and I get negative 8 divided by 8, which gives me negative 1. So my axis of symmetry is x equals negative 1. Okay, that also tells me the x value of the vertex because the axis of symmetry goes through the vertex. So we know that's a negative 1. Now how do we find the y value? All right, well let's take a look. So we're going to go back into our calculator, go back into y equals. you're going to go ahead and clear out anything that's in there. And we're going to put this equation in. So we have 4x squared plus 8x plus 15. Okay, so make sure you get that in. Pause the video if you have to get it in. So now we know the x value of the vertex is -1. Let's go look at this table of values. It's right above the graph, so you have to press second graph to go to the table of values. And I want to go to where x is -1. When x is -1, y is 11. So now we know the vertex is -1, 11. Now I want to point out a little something there. Look at this 11 and look at the number above it and below it. They are both a 15. You will see this pattern, it's the quadratic pattern, if you're in the right spot. So if you don't see the number above and below where you're looking are the same, you've made a mistake somewhere. Go back and check your math to make sure you're on the right path. This is because this vertex is the symmetrical spot and the graph comes down and then turns around and changes direction, and so it's symmetrical on both sides. Look, 27, 27, this is 47. When I scroll down, that one's 47. Okay, so from the vertex, it's symmetrical out on your y values there. So now the domain. In our non-real world problems, in our non-word problems, we are never, remember, domain are your x values, so we're talking about the left and right. We're never stopping going to the left, and we're never stopping going to the right, so we're going to have something called all real numbers. That's the symbol for all real numbers. Okay. We previously did -infinity to positive infinity. We've talked about that also. The range is all your y values. It's your up and down. So the range is always going to be in relation to the vertex because the whole graph is either above the vertex or below the vertex. So for this particular graph, all of my y values are above that vertex, so the y values are going to be greater than the y value of the vertex. So all y values are going to be greater than or equal to 11. Okay, let's try this again. We have a new equation, so go into y equals, clear out what is there, and put this equation in. -3x squared minus 24x minus 42. Those are some bigger numbers, but that's okay. Now I know before I even start, my a value is negative, so what I need to do is draw a downward facing parabola. I know that the axis of symmetry will go right through there, through the middle, and here's my vertex. Okay, my vertex is at the top of the graph. That makes it a maximum. To find my axis of symmetry, I take -b divided by 2a. So I get 24 divided by -6. So my axis of symmetry is at x equals -4, which tells me the x value of my vertex, -4. Let's go look in our quadratic. So we have it all put in. Second graph to go look at our table. So I'm going to scroll up just a little bit. I have x is -4 here, which gives me a y value of 6. And when I look above and below, do you see the same number of 3? I now know I'm in the right position. So -4, 6 is my vertex. All right. Now, that's a lot of information. How about domain and range? Remember, domain is your left and right. We just talked about it right there. This graph never stops going left. It never stops going right. In the non-real world ones, you're pretty much going to always be all real numbers. Okay, now your range. Here's your vertex. Your entire graph is below the vertex. So all the y values in the graph are going to be less than the y value of the vertex. So y's are less than or equal to 6. All right, let's try a couple of these so you can go and do the practice. Now, stop the video, get this equation put in, and get your sketch started. This a value is positive, so you know it opens up, but pause the video, get your equation in, and get your sketch started. Right, I have my equation in, I got my sketch started, but I need to know where to look in the table of values. So let's find the axis of symmetry. It's negative b divided by 2a. So it's negative 8 divided by 2, which is negative 4. That tells me my axis of symmetry is negative 4. So I'm going to sketch this in. And I'm going to label that x equals negative 4. I know that my vertex goes right through the same spot as the axis of symmetry, so they share the same x value of negative 4. Okay, so what we need is the y value of that vertex. So go look in the table of values, second graph. If y is negative 4, if x is negative 4, y is negative 1, look above and below, see how they're both zeros, and then the 3 matches also. You're in the right position. So negative 4, negative 1. What else do I know? I know that my vertex is on the bottom of the graph. That makes it a minimum. For my domain, we're never stopping going left or right because there's arrows there, so that makes that all real numbers. And my range, here's my vertex. My entire graph is above. Nothing goes below the vertex because the vertex in this case is a minimum. It's the very lowest point. So all of my y values are greater than or equal to negative 1. Okay. Now, we just do the same things. You need to decide, is it opening up or down? You want to get the axis of symmetry, and then you can use that to get your vertex. So what I want you to do is I want you to pause the video, and I want you to sketch the graph. Well, let's see how you're doing. This graph has a negative a, so your graph is going to open down. Your axis of symmetry, of course, goes right through the very, very center and the vertex. When I found my x value, I found it to be 5. So my axis of symmetry is x equals 5. That gives me the x value of the vertex also. So I put the equation into my graphing calculator. I'm going to go look at the table of values where x is 5. And I get a y value of 2. And I double check above and below, and I see that symmetry coming out, so I know I'm in the right spot. So when x is 5, y is 2. This vertex is sitting on top of the graph. That makes it a maximum. We're never going to stop left or right, so that makes us all real numbers. And our range. The entire graph is below the vertex, so all of my y values are going to be less than or equal to where y is 2. So y is less than or equal to 2 is our range. All right, one last one for something that you could see. Sometimes you don't have all 3 numbers, so pay particular attention to which numbers you do actually have. Remember, the a is always next to the x squared, so we have a. B is always next to the single variable. I have no single variable term. C is the constant, so that negative 3 is a C. So I don't have a B value. If it's not there, that value is going to be 0. So to find our axis of symmetry, I have negative 0 divided by 2, which is just 0. The a value here is positive, so my graph will open up. We know the axis of symmetry will go right through the center of it, and that will be at x equals 0. So our axis of symmetry. Our vertex is a minimum because it's on the bottom. We know the x value is 0 because that was our axis of symmetry. So let's put this into our calculator, go into y equals, clear out whatever's in there, and we just have x squared minus 3. Take a look at your table of values. If x is 0, y is negative 3, and I just always double check above and below so I see that symmetrical pattern. So 0, negative 3 is my vertex. Domain, we're never stopping going left or right because of the arrows. And my range, the entire graph is above the vertex, so my y's are greater than or equal to that y value of -3. Okay, hopefully that was helpful. Let me know if you have any questions. See you in class.
Yeah.